Hey, do you know what this is? This is the last video. That's it. I don't know. You're probably super relieved or sad. I don't know. I don't know what I am. I guess a little bit of both. It's been a long road, but we made it, right? And I'm really bummed actually because this topic in particular, I wish that we had more time to do more with because exponential functions are so relevant to our world right now. Um, so I'm just going to give you a little bit of taste, a little taste of them. Uh, there's so many things that you can do with exponential functions. So the reason why I'm saying that it's coming up in our world right now is if you take a look at coronavirus cases, it has unfortunately grown exponentially. So what does that even mean? Anything that's going to increase, not by a set amount. So let's say, let's just take a very basic example. If I had a job and I got a $10 a year raise, I don't know, right? And I did that for 20 years. That's a linear increase. I'm increasing by $10, the same $10 increase every year, right? But if I got a 10% increase, raise increase every year, well, that's going to change, right? So if I started out making $10 an hour and I get a 10% raise, that's $1. But now the next year, I'm making $11 an hour. And if I still get 10% raise, but now 10% is more than $1, right? Because 10% of 11 is now going to be $1.10. So now I get an even bigger raise. So now the next year I'm making, what am I up to now? $12.10, and now I get another 10% raise. So what ends up happening is every time you get that percent increase, it's going to get bigger and bigger and bigger much more quickly. Okay, so there are a few things that we want to grow exponentially. Your money, right? So this is why, if you've ever heard anybody, I don't know, maybe I was not into personal finance very much when I was your age, but now I super am. And I love talking about personal finance. And if I just can give you one little bit of advice, as soon as you can start right now. You don't have to wait. But you need to, I know it's going to sound crazy, but if you start saving for your retirement now, oh my goodness, because here is exactly what's going to happen to your money. Let me show you real quick, real quick. So even if you probably don't have a lot of money because you're young, you probably don't make a ton. I mean, if you do, great, good for you. But most of the time, you're not going to make very much. So let's just make this a baseline, right? And let's just start with an axis, right? Okay, so you're just starting. You're not going to make that much money, but you decide to set aside, I don't know, even if it's $10 a week. Okay, let's just say that. So there's like 2 trips to Dunks. You decide to just suck that away into a retirement account. So at the end of the first year, you're not going to have that much, right? But that money's going to grow. If you put it into the right accounts, it's going to earn interest. So it's not going to grow by very much in the beginning, right? So for a bunch of years, it's just going to kind of look like this. You're going to keep putting some money in, but I mean, it's going to grow, but very slowly. You are earning interest, but eventually, if you keep putting money in and it's going to keep earning interest, what eventually happens when you have a lot of time, like you would, right? By the time you go to retire, you're going to have reached a point where your money kind of does that. Oh my gosh, it's so cool. There's so many calculators online that you can kind of play around with and just say, all right, well, let's just say, okay, let me do the $10 a week. And let's just see, if I put $10 a week in for, 30 years in an interest-bearing account, where am I going to end up? Oh, it's so cool to kind of play around with it. And then, so as you get older too, I mean, hopefully you're not only putting $10. Hopefully as you get older, you'll get more skills, you'll get better paying jobs, and then maybe you can afford to put more than $10 a week. And so anyway, you just build and build and build. And then, depending on how smart you are with your money, the point where this takes off could happen even sooner, right? So anyway, I love tracking money. So I've always wanted to like start a club, or I would love to do a class on it, but I don't know. Anyway, like, Miss Sabia, this is our last video. Would you shush and just tell us about this? Like, well, I'm going to use this. Well, yeah, you might. If you're lucky, your money is going to grow exponentially. So anyway, let's talk about exponential growth. That's your general formula for exponential. Where's my, is my computer lagging super hard? Okay, my computer's being a little laggy, so I'm gonna get to the point here. So there's your general form for an exponential function. If b is some value greater than 1, if b is greater than 1, you have exponential growth. So what that means is that if your graph is going to basically look like this. That's the basic shape. It's going to start off small, and then it's going to grow, and it's just going to keep on growing. This thing just keeps on going. And so if that's money, oh my gosh, so exciting. On the flip side, if b is something less than 1, so any fraction, right? So if it's a half, a third, 2/9, any fraction less than 1, what you're going to have is exponential decay. Exponential decay. And there's a lot of things that have exponential decay that you care about. So another just basic example. If you buy a brand new car, which I actually kind of advise you not to do, especially when you're young. That's just my personal opinion. But anyway, the reason why I'm telling you not to do that is because when you go, if you get your first job and you go to the dealership and you're like, ooh, I want this $40,000 or $50,000 car. Okay, fine, buy your $50,000 car. Guess what happens when you drive off the lot? It drops in value immediately, because now, even though you literally just drove it like 100 feet, it's now a used car. Immediately. Okay? So you lose. If you decided to turn around and bring it right back to the dealership and return it, you don't get your full $50,000 back. So new cars are going to drop in value super fast. Okay? So they start off super high, and then they're going to quickly drop off, but then they kind of level off. So that's kind of the shape for an exponential decay graph. Keep thinking about it with a car. Is there that much of a difference in value between a 9-year-old car and a 10-year-old car? No, they're both old. Like, nobody really cares that much, but people care a lot if it's brand new or 1-year-old. There's a big difference there. There's still a big difference between 2 years and 3 years, right? So those things matters, and it matters a lot more in the beginning. So you have this quick drop off, and then it kind of levels out. So card depreciation, there's exponential decay. Have you ever wondered how, like, when they opened up King Tut's tomb, right, and they were able to like figure out how old everything is, how do they know? You think it's got like a date stamp on the bottom of the golden urns and stuff? No, there's no date stamp, right? So what they're doing is something called carbon dating. So basically, carbon, and it's not the only thing, but there's lots of elements that have what's called a half-life. So after a certain amount of time, half of it decays away. So if I started with 20 grams of carbon-14, I don't remember what its half-life is. I used to know it, but I don't anymore. Let's just say for easy numbers, right? So if I have 20 grams of this carbon-14 and its half-life is 100 years, I have no idea what it really is. That means after 100 years, I'm only going to have 10 grams left. After another 100 years, I'm only going to have 5 grams left, and so on and so on and so on. Think about taking half of a number forever. It doesn't actually ever go away, right? Mathematically, you can take half of a number forever. So what they can do is they can test how much there is left and then work backwards to figure out when that item originated. So cool, right? Anyway, now, how are we going to graph these things? Let's see. So now again, we're just sketching. We're not being super specific here, but here's what I need you to be able to look at. I want you to look at whatever is being raised to the exponent. So in this case, it's 2. 2 is being raised to an exponent. So first thing I want to decide for myself is this going to be exponential growth or decay? And how do I know? Remember, if that number is bigger than 1, it's growth. If it's less than 1, so some fraction, it's going to be decay. So in this case, I'm going to have growth. So that means my graph is going to look something like that. Going to start off little and then shoot upwards at some point. All right. So really, I mean, let's start off by finding the y-intercept, right? So if I plug in 0 for x, 2 to the 0 is just 1, 4 times 1 is just 4. So this thing is going to cross the y-axis at 4. And then really all I need you to do from here, since I know it's going to be growth, I know it's going to come along the bottom here and then it's going to shoot up kind of like that. If we had more time, we'd kind of get into the nitty gritty. You can plug in more values, certainly, if you want to get a more precise graph. Plot, plug in -2, plug in +2. And you can kind of get a more precise graph, but that's really all I need to see. Do you have it as growth or decay? And do you have it hitting the y-intercept in the right spot? Okay, so let's try number, oh my goodness, of course I would do this on the last video. Ooh, look at this one. So this one is a growth or decay. Hopefully you're realizing very quickly this is going to be decay. How do I know? Because the thing being raised to the exponent is less than 1. So let's just go ahead and plug in 0. That would be 1/2. So this thing is going to come from up high and then hit and then sort of ride out along my x-axis. Okay, does that make sense? Let's try 3. Ooh, another decay graph. How do I know? Because it's 1/2 being raised to the exponent. Pop in a 0 for x. I'm going to get 3 times 1, which is just 3. So if this is decay, it's going to come from up high. It's going to cross at 3, and then it's just going to ride along that x-axis, just like that. All right, guys, that's pretty much it. So just try the other ones. I do have a review activity for you tomorrow, and then you're done. So I'm sorry that this year kind of turned out the way that it did. Gosh, I hope that you learned some math. And I don't know, I wish you the best, and I hope to see you in the fall. Please reach out if you need absolutely anything. Okay? All right. Bye.